We are discussing about the straight lines. Point of intersection of two lines. Two lines, if we assume the general form of first line will be a1x plus b1y plus c1 equals 0 and a2x plus b2y plus c2 equals 0. Now suppose these are the two lines and they are intersecting. The point of intersection, there is a formula for this. There is a coordinate, say x and y. So what will be x? X will be b1 c2 minus b2 c1 by a1 b2 minus a2 b1. This is the x coordinate, and y coordinate is c1 a2 minus c2 a1 by a1 b2 minus a2 b1. So these are the point, or these are the coordinates when two lines are intersecting. So in order to find the coordinates of point of intersection of two non-parallel lines, we solve the given equation simultaneously at the value of x and y. So obtained, determine the coordinates of the point of intersection, right? So if they are parallel, that means these points will not be there. There will be no intersecting point, right? So this is the point of intersection of two lines. Then we are coming to one more thing, which is the condition of concurrency of three lines. Concurrency of three lines. So we have three lines and they are concurrent. That means they all are passing through the same point, same single point. This is the one line, this is the second line, this is the third line. All these three lines intersect at a common point. Okay. So we will use the previous result here. That is, we have one equation as a1x1 plus b1y plus c1 equals 0, and we have the second equation a2x plus b2y plus c2 equals 0, and a3x plus b3y plus c3 equals 0. So we already have an intersection point of two lines. We just saw it. These are the 2 points of intersection of two lines. Now there is a third line which also holds this point. So we have third line, which is a3x plus b3y plus c3 equals 0. So when two lines are intersecting and third is also passing through that means these points lie on this line, third line also. This point is also lying on the third line, so it needs to satisfy this line. So a3, and now in the place of x I am putting b1 c2 minus b2 c1 by, this is a1 b2 minus a2 b1. This is the x point, which happens to be on this line also, and b3, which is now the y point, which is c1 a2 minus c2 a1 by a1 b2 minus a2 b1. So now the y point is there and this c3 equals 0. So now when this equation, you can rearrange it, reorganize it, so you will get a proper equation, and the equation is determinant. So I hope you are able to find out the determinant, or the formula which I just told you, you can use directly that also. a1 a2 a3, b1 b2 b3, c1 c2 c3. So the determinant of this equals 0 is the required condition for concurrency of three lines. There is one more condition that can be there. So L1, assume it to be the first line, a1x plus b1y plus c1 equals 0. So this is L1, line 1. Then we have line 2, a2x plus b2y plus c2 equals 0. Then L3 is a3x plus b3y plus c3 equals 0. So we have three lines and they are concurrent if there exist constants lambda 1, lambda 2, lambda 3 and they not all 0. So the condition will be lambda L1 plus lambda 2 L2. So L1 is a1x plus b1y plus c, you have to replace here. lambda 2 into L2, that is A2x plus B2y plus C2, and lambda 3 into L3, A3x plus B3y plus C3 equals 0. So this is the condition of concurrency of three lines. Now we have